Hi guys, and welcome. Today I want to take you through the steps I went through to create the files for this, the Wood Carvers Mallet I did in my last video. For that, I started with the stock material. I originally cut it out as a square, and then from the square I took 3 measurements. I measured across the flats 75 millimeters, across the diagonal 107 millimeters, and its overall length 270 millimeters. From these 3 measurements I then create the file to turn that into a cylinder. It's important I do this first, that way I know how big the material can be before I create the file to make the actual mallet shape. If my wood isn't big enough, I can either throw it away and get another piece, or more likely slightly adjust the file so that it suits the piece of wood I'm using. The program I'll be using for this project is called CNCWrapper. I'll put a link in the description box below to where you can download a trial version and also where you can buy a license for the full version. It has several functions. One is this one here, which is wrapping a flat object onto a cylinder, which we'll be using in the final stages to actually cut the mallet shape. And we have this one here, creating a rounding file, which is the one we want at the moment. So let's have a quick look at some of these bits and pieces here. We need to tick which ones apply here. In this case, our tool is traveling in the X direction, or across the X axis. We don't have a Y on the machine setup we've got. We're calling our rotary axis the A axis, and we want to cut in both directions, left to right, right to left. Now we need to put in here a safe Z, and I'm going to put in a figure of 10 millimeters. That's 10 millimeters above the highest point we're cutting. And the same goes for the clearance. I'm going to make that 10 millimeters as well. Now a couple of things I should mention here is if you're using imperial, simply enter in the figure. So if it was imperial, you would add in 0.375, which would be 3/8 or 10 millimeters. The second thing is the x-axis in this program is referenced to the center of the lathe. So that's something to be mindful of. X0 is in the center of our material. So our start diameter here of our stock is 108 millimeters. I've added 1 extra millimeter to the 107 millimeter I measured on our stock. That gives me a little bit of extra clearance should the material be off center when I put the spur in and the center at the other end on the tailstock. We're not going to worry about the number of cuts at this stage, but we are going to come down here and go to our finished diameter. Now I want our finished diameter to be 73 millimeters. That's 1 millimeter bigger than I plan for the item to be when I'm finished. Again, just for a little bit of extra clearance, and the fact that this is a roughing cut, not a final cut. Now we can go back and look at the number of cuts. If we take 73 away from 108, we're left with a figure of 35. That's 35 millimeters of material we're removing from the stock to get it down from 108 to 73. But this is a lathe, so in actual fact the cutter only has to travel half that distance because it takes it both from the top and the bottom at the same time effectively. So that's 17.5 millimeters of material that I'll be cutting away. Now ideally I'd like to make cuts passes of 1 millimeter each. So if I put in here 17, that's close enough. That will give me 17 cuts of just fractionally over 1 millimeter each. I don't want to overload the cutter because as it rotates, it's going to be bashing into those four corners, and that's going to put extra loading on the machine. I don't care how long it takes to cut this out. I'll just let it run. So there we have it. 17 cuts and roughly 1mm each. Next we need to define our X start and end positions. So we're going to be starting at X0, which we'll be setting at the extreme left hand side of the material, and we'll be finishing at 275. I've allowed to run a little bit past the end of the material to ensure it cuts the whole thing properly. Now, another thing to bear in mind is this program does not know the width of the cutter. It doesn't care how wide it is. It does not take that into account when it is machining. So it will literally follow the directions that you give it. In actual fact, I will make this 270 millimeters. Now, tool diameter. I'm going to use a 12mm cutter. So I want to remove material quickly, and that will be by far the quickest way of doing it. Step over. I'm going to use 40% step over, and the step over here is the same as it is in any 3D modeling program, or 2D modeling program when you're doing a pocket. Tool number, really only relevant to those who are using an auto tool changer on their machine. Otherwise, just leave it to tool number 1, really. Plunge feed. That's how fast the plunge will be on the cutter. I'm just leaving mine at 500 millimeters per minute, which isn't overly fast. Cut feed rate. I'm going to enter 30,000 into here. That's again millimeters, or 30 millimeters a minute. 30 meters a minute, sorry. On Rotary Axis, that figure does seem large, but it actually doesn't translate to a huge amount of speed. I want it up on the larger side though, and then I can use the feed rate altering tools in Mach 3 to adjust the speed to something that looks better, either a bit faster or a bit slower. I haven't quite figured that one out yet, but I'll just go and put 30,000 on at this stage. Spindle speed. For those of you who are using the speed Mach 3 to adjust your spindle speed, this is where you put it in there. And then we just simply hit create rounding code. And there it is there. Up the top here, it gives all the information about how it was created, what time it was created, how much our cut depth is going to be. So it's going to be about just fractionally over a millimeter, what our tool diameter is, start diameter, finish diameter, and here is our Gcode there. So we can now save our file. Go down here, save as, and I've selected my F drive, which is my USB stick. I'm going to create a text file, and I'm going to call it rounding stock, and we'll just save that. And that's all there is to creating a rounding file to change our square stock into a cylinder. I've now completed the rounding toolpath I created, and this is the finished result. The good news is, when I put the calipers on here, it measures 53 millimeters. Also, there are no flat spots on it when I rotate it, which means that I got the full 53 millimeter diameter cylinder out of my piece of stock. That means I don't need to go altering my file to any great extent to make it fit my stock. But one thing I do notice here is this. There's a crack running up here. It looks like that crack sort of runs parallel to the sides as a tangent rather than to the center of the material. So hopefully it's not going to be too bad down this end. Plus what I'll do is I'll make the head of the mallet here, and that'll be curving off there a bit as well. Hopefully the crack will disappear, and if it doesn't, hopefully it won't be too bad. We can only try and see. One thing to be mindful though is I've got the spur driven into this end here, and I've got to be careful that I don't hit it when I create the file. for cutting out the mallet. I want it as close to this end as I can to get away from this crack, and so I'm going to have to just bear that in mind when I'm creating the file as well. So here's a little tip for making this here run a lot quieter on your machine, is where the tailstock goes into the end of the material here, put a little drop of oil. I just got a little drop of oil out of my oil can into the little hole there where the tailstock sits, and that really quietened the thing down, became silent. Before that it was squeaking something terrible, it was driving me around the twist. Tiny drop of oil and the noise goes away. It runs a lot smoother as well. And it doesn't matter the oil soaks in, because it's going to be cut off anyway at the end of the day. It won't soak in very far at all, especially into wood this dense. So there's a wee tip for you, a little drop of oil, and this will run a lot smoother, a lot quieter. We start by drawing our basic mallet shape, and I'm just doing this here in VCarve Pro. Basic 2D drawing. All we're doing is we've cut the mallet in half and are looking straight down on top of it, and this is what we see. Now what I need to do is at the very ends here where we're going to machine, I need to put some holding tabs of some description. So what I'm going to do is I'm going to do this. You can see here these tabs, they've got small sections here, but they taper off like so out to the size of the stock. Now that's important. I don't want the cutter plunging deep into this material, because the cutter blade is only a certain depth, and if I try and plunge it straight into the material to get down to this final depth here, I'm going to run into problems. It's not all going to be cutter blade. I could end up snapping the tool. So by just putting this slightly flared flared section on here, and I made it a 5-degree flare, it should force it to bring the cutter down into steps to get down to this final diameter here, and that's only 10 millimeters across here, so I'm going to be using basically 10 millimeters of unmachined area to hold this mallet in place, and that should be more than enough. Now the next thing we need to do is we need to we need to split this in half, because of course we only need to machine half this, because this is a lathe. We only need to machine it in half. So what I'm going to do is I'm just going to run a line straight from top to bottom, and I'm just going to grab that line and make sure it's in the center. It is, and I'll actually just grab my mallet and make sure it's in the center, which it is. And now with the cutting tool, I'm just going to cut it like so, and cut the top and bottom. Now of course you can use any CAD software that you want to do this. I'm familiar with VCarve Pro, so that's what I choose to use, but any 2D drawing software will get us this far. Now I also need to rotate this, because otherwise its orientation will be wrong. So I'm just going to rotate this 90 degrees. Whoops, wrong way, so we'll just keep going, and there we are. So this is looking at the lathe. This will be the end where we're starting our machining, and this will be the right hand end at the tailstock end, tailstock, headstock end. So my orientation is correct. And to be honest, I'm not bothered about where it's sitting on my material, but we'll just grab it like so, and if I put it on a piece of material 250 by 36, 250 wide and 36, and I'm going to take my material thickness 36 as well for good measure, and I'll also just center it. Okay, there we are. And I'll also make the position of 0 just down here. Again, I don't believe this here is a major requirement. As long as we've got this here set right, I'm just going to save this, save as, and call it mallet, call it half mallet. with tabs. Now I'm going to grab this and I need to export it as a DXF file. So I'm going to call it mallet.dxf. Right. Now we need to convert this into a 3D model. I've now opened Turbocad Delux version 14. It's an old version of software I've got. And I'm just going to open our DXF mallet file that we created before. And there it is there. The only reason that I'm bringing it into here is to convert this into a 3D model. And basically I'm going to take my drawing and extrude it. And that is all I want to do in it. I'm not even worried about by how much I extrude it. I will sort that out when I bring it into Cut3D. All I want to do is create a 2D drawing into a 3D one. So I can now save this as, and I'm going to call it 3dmallet.dxf. And that's that. The first thing I'm going to do is I'm opening Vectric Cut3D, but you would simply use whatever software you would normally use for doing 3D machining work. And the first issue I can see here is that while X is running in the right direction, Y is actually incorrect. That's going in the Z direction there. So what I'm going to do is I'm going to click here and change my X, Y location. Now I've got a Z of 36 millimeters. That's correct. X is also correct. And I have my Y setting here. What I need to do is I need to find out how big it should be along the Y. So by going into CNCWrapper Tools and Show Design Calculator, I can enter into here my job diameter of 72 millimeters, my angle of cut, how many degrees I will be wrapping this around my A axis, in this case a full 360 degrees, calculate, and this is how long the Y dimension needs to be on my 3D model, 226.195. So I will unlock this here and change this to 226.195 and apply. That is why I didn't care how much I extruded it in my 3D program. All I wanted to do was make sure this was converted to a 3D model, and I take care of it here. So that's all I need to do here. Just going back there, you'll see I've got millimeters checked here. Obviously, if you're doing it in inches, you would have inches checked. Right. Next, I need to just make a quick change here. That's going to be 36.5 millimeters for my stock, because if you remember, my stock is currently 73 millimeters in diameter, or a radius of 36.5. I also need to change where my origin point. Currently, it's in the center top of my material, and center bottom of my material. I need to change it so that it is at the bottom left hand part of this model, and there it is there. It's now moved down to here, because I'm going to be machining using the center of my stock as a reference, so I need to have this here set to the bottom, not the top. I also need to uncheck symmetrical and make sure these are all 0. If I do not do that, it will try and machine around my entire model, including the outside here and the two faces here and the one on the other side. Try and basically cut the model out as it machines it, and that we do not want at all. I also need to set here that the depth of my model is 0.5 millimeter below the surface, and make sure I click bottom to say that we will be machining right to the bottom of our model. Okay, we're now ready for a roughing toolpath. For our roughing toolpath, I will be using a 1/4 inch end mill. I'm going to use a step over of 40% and a feed rate of 600 inches per minute. Now that may seem a lot, but on the rotary axis for this job, it really isn't. I'm going to have a rapid clearance gap of 5 millimeters. I don't want to make that too high because there's not a lot of room in my z-axis height. So I'm going to just keep that nice and low. There's no need for it to be high either. There's nothing in the way for it to hit. Machining allowance, 1 millimeter. That'll leave 1 millimeter of material on the model when I'm finished. Again, this is all just standard machining stuff when you normally would machine this out of a flat piece of wood, as you see here. Strategy, I'm going to go for Z-level machining, and I'm going to go across the Y-axis. I find I get a better quality of cut when I machine across the Y-axis. So that's just my suggestion, go that way rather than machining up and down the X-axis. One important thing though is normally profile is set to last. Set it to none. CNCWrapper cannot handle curves, and if you leave that set as either first or last, it will produce files that have curves in it. So just get rid of that. We'll calculate this and move on to the finish toolpath. So now that the rough cut is complete, I have changed my tool bit to a 6mm ball-nosed cutter and re-zeroed it off the tabletop here. I've now loaded up into Mach 3 the wrapped finishing toolpath that we created, and nothing remains but to do the final cut. For the finish toolpath, I'll be using a 6mm ball-nosed cutter. I'm going to use a 3% step over, feed rate of 600 inches per minute, a rapid clearance of 5 millimeters, and a raster angle I'll be machining along the Y-axis. Now that our finishing toolpath is complete, I want to look closely at that sloping piece that I drew in earlier. Here's our holding tab, and here's the sloping path from the surface of our material down to the holding tag. You'll see here the toolpath that's been created moves its way slowly here, and then slowly it starts working its way down this material until it reaches the bottom and starts machining this piece here. Now remember, I've left 1 millimeter of stock to be machined off in the final hit. Now if this here was vertical, the cutter would plunge the full depth in one hit, and it will be 1 millimeter into this side wall here. The flutes on your cutter probably are not long enough for that sort of nonsense, and even if it is, that's a pretty big ask for the cutter to cut all in one hit. So by making a slight 5-degree slope here, the cutter can gently work its way down to the bottom there, takes very little extra time, and it can then start machining the rest of the model. So that may not be the best way or the correct way to do it, but for me at this stage it looks like the best way for me to do it anyway. We'll now move on. We don't need to do a cutout toolpath. We don't need to preview our toolpath. All we really need to do now is save our toolpath. So I'm just going to go roughing toolpath save, and we'll just save it in my Wood Carvers Mallet directory. I'll just replace the old one and the finishing toolpath. There we go. I'll replace the old one. And there we have it. That's our cam work done. We can now open CNCWrapper and wrap our model onto our axis. Now that we've created our 3D model in Cut3D, or whatever CAM software it is that you're using, We're now going to import that into CNCWrapper. I'm going to go Open File to Convert and select my roughing toolpath to start with. Now it's come up with an error here, floating point division by 0. That's because over here I don't have either a diameter, radius or circumference entered. The diameter of my finished mallet will be 72 millimeters. And just as a word of warning, don't click one of these three boxes when you enter the thing, the figure. Just come over here and click over here somewhere. Clicking either of these three boxes will clear the lot. Just check that you've got y-axis is going to change to the A, so any mention of the y here changes to the A. Then go Start Code Conversion. Here is our new code. The y entries have disappeared and they've been replaced with A ones, which are in degrees, not in millimeters as they were before. We can now go save the file. It'll put it back in the original directory. I'm going to select it as a text file rather than a tap one, and it's going to have the word wrapped added into its name. So we'll just go save. I can now open another file to convert. We'll do the finish toolpath. Open that. We don't need to change that. We'll just go Start Code Conversion, Save File, and there it is there with the name wrapped. The two files with the word wrapped in it are the two that we will be cutting on our machine. And that is all there is to wrapping a file using CNCWrapper. Very good, easy program to use. Well, there's no doubt about it. If your aim in life is to create sawdust, this is just the perfect machine for you. I'll put a link in the description box below to where you can download a trial version of CNCWrapper to try out for yourself and make sure it works in the way you want it to. So here's the completed mallet that I made, and while I was at it I made another. That of course now gives me 3 in total. If I perhaps make another 7, I'll be able to start my own bowling alley. Well, I hope you've managed to stay awake throughout this tutorial and have gained something from it. If you've enjoyed this video, please remember to like it. If you haven't already done so, please consider subscribing to my YouTube channel and follow me on Google+. In the meantime, I'm going to go and practice some juggling. We'll catch you guys later. Cheers. Damn it.